Todd, I'll start with an introduction. My name is Patrick Lane, and I work for, of course, the Montana Department of Transportation here at the Helena headquarters building. The transportation here in Montana, the big organization, right? We have roughly 2,000 employees. We're spread across 5 districts. We have designers, engineers all across the state working toward delivering the transportation program here at MDT. We typically deliver roughly $500,000 worth of contractor payments in 1 year's time, which gives you kind of an idea of how busy we are and how much transportation infrastructure we manage and maintain. Several years ago, Lenci and I set out to educate and implement a 2-year roadmap for the initialization of digital delivery here in Montana at the department. And as part of that digital delivery effort, we started looking at how we do business from a workflow and a process standpoint. Prior to that, Lenci was instrumental in working with the Autodesk team to bring some of the Autodesk tool sets into Montana, into our bridges and structures division, because we currently felt like some of the tool sets that we were using on the roadside had left bridge kind of behind. So what had happened is Lenci ran a proof of concept, and we ended up signing a 3-year commitment with Autodesk and started doing bridge design using the Autodesk tool set. With that being said, we also went out for an RFP to look at the entire CAD infrastructure here at MDT back in April of 2001. We signed a contract with Team DLT, which consists of Autodesk, US CAD, and DLT, the reseller, to not only implement the AEC collection from Autodesk, but to assist with project management, training, and maturing workflows, working with our teams from a technical perspective, mentoring, the whole nickel. And so through that partnership with US CAD, we were introduced to Matt Vega, who's the director of government affairs there at US CAD. Lots of exciting conversations have happened, were happening at the time. This was back, we kicked off the implementation for road. Lenci and Brandon, of course, were involved in that. Lenci was the pre-construction point of contact for the implementation for all of MDT, and Brandon was the construction contact or the construction liaison for MDT. The two of them joined Matt and I on the core team for the implementation. And as you can imagine, not just from a digital delivery standpoint, but from an Autodesk implementation standpoint, we were all pretty excited as to what the future might hold. That excitement really took off right around the 30th of November last year in 2021. Matt and I were in Connecticut at the IHEAP conference. And during that conference, roughly the evening of December 1st, Lenci had contacted me and had shared some terrible news that here in Montana, we actually had a wildfire called the West Wind Fire, which was ignited outside of Denton, Montana. It actually crawled into the community. It burned over 20,000 plus acres, including 25 structures, several businesses, several homes. Thankfully, no lives were lost. However, we realized when the emergency services crews were able to extinguish the fire and start to assess the damage, that there was major bridge damage to one of the primary bridges entering the town of Denton. That's when Lenci became involved as a structural engineer here at MDT. And part of the excitement from a design and a digital delivery standpoint was Lenci called me and said, Pat, this will be a great opportunity for us to look at all of the work that we've been doing with not just digital delivery, but with the implementation of Autodesk into the bridge and structures division, as well as the workflows that they've been working on and how they've been able to collaborate and begin to see the vision of delivering bridges in a new manner here at MDT. We felt that this project would potentially provide us an opportunity to assist the other functional engineers and the executive management team here at MDT in getting this rebuild off the ground. I personally wasn't involved in that, but Lenci was. And so from that standpoint, when we talk about the Wolf Creek Bridge outside of Denton, Montana, the terrible fire that destroyed it, and the amazing accomplishments of many parties to rebuild that for the community, Lenci Kappes will bring us up to speed on some of the technicalities and behind the scenes processes that took place to make that amazing feature what it is today.
As Pat mentioned, Brandon and I are fortunate to wear a lot of hats here at MDT. My primary role is a bridge engineer in the Bridge Bureau. My role is actually innovations and complex structures engineer. And through that role, I got to do a lot of things. One of those is to tackle some of the hard problems, and one of those is to figure out new ways to do things. And that's one of the things that's led MDT and our Bridge Bureau down this path, to really sharpen our saw and get the tools we need to be able to respond to an important project like this, as well as just have the tools to be able to deliver the bridge program that we're doing. One of the important things that we've done in this role is be able to work not with just Pat, but with highways, or I should say through Pat's. We have digital delivery initiatives and all sorts of different initiatives, but the primary goal is to bring all of our department into the same playing field so that we can collaborate and deliver projects better, more efficiently, and just better than we have in the past. And I think that's one of the most exciting things about the Wolf Creek Denton project is this catastrophe came up within our state, and instead of just wanting to help, we were able to put our hand up in the Bridge Bureau and say, we have the tools, let us have this one, we can deliver this one. And so that's, I think, one of the biggest things that we did on Denton that we're excited to talk about right now. Yeah, so this is a very unique project. A bridge burns down basically overnight, and MDT needs to respond. And so a lot of times we'll go through design, bid, build within a standard delivery. Obviously, this was not design, bid, build. It was actually design, build. And that typically means a consultant engineer and a contractor are going to work together to provide the solution. With the emergency aspects of this, we weren't able just to reach out and do that because our consultants are busy, we're busy. It's very hard just to drop everything and be able to respond to this. And so it was kind of neat. As I mentioned before, we had the tools, we had the expertise, we could raise our hand and say, let us have this one. And that's exactly what we did. Not only did we talk to Pat, but we reached out to our Bridge Bureau chief, who was in direct contact with our department engineer. And I said, we have software that'll eat this for breakfast, let us have it. Well, there's still the contractual side, and that's where we're able to combine everything together. So we actually had a couple bridges down the road that we were still under contract with. And so we started looking into our alternative contracting methods. As Pat mentioned, we do CMGC, we do design build and JOCs, all sorts of things. And we looked into this and we said, we have a project going on. Can we do this bridge as a change order? And if so, what would that look like? And so when we started to reach out to our engineer and contractor on those other bridges, They were game to help in any way that they could, but they were a little short-handed on their engineering staff to be able just to pick up a project like this one. And that's where we were able to combine forces, MDT engineers with the contractor and then that outside consultant engineer. And is what was really cool is the software is what allowed us to all work on the same things quickly, efficiently, and very streamlined. The consultant engineer didn't have 40 hours a week. He was hoping more for like an hour or two a week to oversee this project. And so engineering used to be in Excel charts and hidden programs and all these different calculations done a lot of different ways. And then at the very end of a project, you'd compile them together in your final plan set, and that's when everybody can start seeing the same things. Well, in the tool in the new workflows that we actually can create a bridge model up front and then start piecing together calculations, and we can tweak the model. We can work with hydraulics. We can change the skew on the bridge. We can change the length. We can change the number of spans. And we did all those things real time in this project. And so the coolest thing about this is we had MDT engineers doing this bridge design. We were working in a design build atmosphere with this with Morrison Merrily and then the contractor Frontier West. And so it was really neat to have Jim Scholes, a big bridge engineer here in Montana. He works for Morrison Merrily. And then we had Craig Lean, who runs Frontier West, the bridge program there, or the construction program for Frontier West for bridges. We were able to basically have them looking at our bridge designs over our shoulders virtually. And so we would come up with a design. We're working with hydraulics. We're spinning around the same models. We're saying, what is the skew? How is that going to affect the floodplains? Our hydraulics folks here at engineering or at MDT, we're taking our bridge model and putting it in Civil 3D and then tweaking the survey, which is also another important thing. We're out surveying in the middle of January. There turned out to be, there was 7 feet of ice, I believe, that we dug out of there. That was obviously not picked up in the survey, right? And so there's a lot of things going on that we're having to react to on a very quick basis. And so this over the shoulder type design atmosphere that our software allowed us to do allowed us to match up the engineering, the analysis, the structural part, the hydraulic components, the environmental components, and place them all in one place and keep tweaking them on a very real-time basis so that we could deliver this with all parties keen on what we were doing. So it was definitely, Pat mentioned CMGC, and that's definitely what it felt like. Contractually, it fell under a design build path and delivery, but definitely CMGC with that, the owner, the engineer, and the contractor all working together is definitely how this felt. And CMGC is meant to really bring that ownership around. And in this case, we brought the collaboration together through the tools because we could all see what we're working on. There's also a railroad bridge that burned down adjacent to our structure. And during this, of course, when you're doing hydraulics work and there's another bridge that's going to be replaced, we have to account for all of that. Our design needs to be aware of that, and our hydraulics work, floodplains and all that stuff has to be aware of that. And so it was very crucial midway through this, when we were talking with the railroad plan to replace their structure and even their temporary fix, which consisted of 4 culverts, it was so powerful to be able to bring up our bridge model in a geographical type setting where we could spin it around and then show their plans next to our proposed bridge and make sure that their temporary solution wouldn't detract or hinder our bridge. And so we actually were able to change the alignment of their culverts to better align with our new structure. as well as just show the railroad folks, the bridge designers there, what we were planning. So there's a lot of examples throughout this where not only did we deliver this very quickly, on the design side, but we were able to do, I think we were able to collaborate better than we've ever done on a project. And it wasn't just a few folks in our bridge department or something like that. It was across MDT, and with a consultant engineer on board, with a contractor on board, as well as tying in with that railroad structure and its considerations.
Sometimes a picture's worth 1,000 words. And I'm basically, as you can imagine, we're very proud of the work that the engineering team did on this project. And we've done a few different presentations on it. One of the things that I'd just like to show is this is some actual footage of the structure as it was burning. This is what the structure looked like after the emergency services team was able to get the situation under control. This is some footage of the emergency repair with the culverts Lenci was talking about, where our maintenance team deployed very quickly. Now, one of the things that is extremely interesting and unique about this project is in a matter of 1 to 3 days, we go from a wildfire, and I'm assuming you understand that conditions need to be dry, conditions need to be windy when you have a wildfire, to a situation where you're laying an emergency repair in with culverts, and all of a sudden you have a weather front in Montana move in. And this gives you kind of an idea of the team effort that went into that. Now, in this picture, what you're seeing is the emergency repair for the roadway, but behind that is also very important to see that railroad structure that burned as well. When you're dealing with a community that has literally an access point to one side, could be the north side or the east side, and then the other access point would be to the other side. You have 205 people that are in Denton, Montana, and you have this route, Highway 81, into town or out of town, and then the other side of it into town or out of town, and that's it. And then all of a sudden, this fire burns the community. Now, what you can see here are, of course, grain elevators, a very rural, very agricultural-based community. And of course, this time of year, they're also looking to move crops, and hence the railroad. So not only do we have transit for the community disabled, we also have the railroad disabled. And as you can imagine, infrastructure like that's critical to a community of this size. So that's why this project is at the hearts and minds of everyone at the DOT. And, then we go through and show these photographs again. One thing that I want to reiterate as to what Lenci said is that when we look at what we were able to accomplish, I want it to specifically be known that without the engineers such as Lenci Kappes and Trevin Burkhartsmeyer and the other, functional engineers, road design, Rebecca Barbula, there were many people at MDT that participated. The survey teams led by Bill Weber, everyone, it was all hands on deck in the middle of winter to capture this information. Now, I know Lenci talked about this briefly, but you also have to remember with all that water building up and all of that snow and snow melt, you can imagine how complicating it would be to get a hydraulic survey. You can imagine how almost nearly impossible it would be to have surveyors provide Lenci and the design team with an accurate survey for starting a bridge design. Well, because of the workflows that our bridge team had created and deployed prior to this burn, we already had the steps in place to begin the designing without that natural survey delivered. And back to what Lenci said, then we start talking about the collaboration. We start talking about how we were able to look at the hydrology, how we were able to look at exactly what was being proposed as a solution to that bridge, not from a 2D plan set, but from a 3D parametric model. And of course, this model was important because it showed the challenges that were taken into consideration. What you have to keep in mind is that by removing this highway bridge and then by removing the railroad bridge, if the highway bridge was built incorrectly, it would flood the new railroad bridge. The hydrology, because of the Wolf Creek, was very important and critical. And never before here at MDT had we had such a collaborative effort to get through hydrology challenges like we had with this project, because the hydraulics folks were allowed, using the workflows, to see the design model and then to overlay their model from SMS into this so that we could truly see a floodplain model with the design model and know that we were on to the correct solution and the best built bridge project for this location. That bridge was then sized, and Lenci had to begin ordering parts. One of the things that we also have to keep in mind is that when this happened, we were in the middle of a pandemic. And one of the challenges that Lenci ran into early was that he ordered, or was attempting to order, bridge piles. And he found out that the bridge pile sizes that he was looking at ordering were unavailable and would not be available for quite some time. And so by creating a parametric design, Lenci was able to find out what bridge piles, what sizes were available, and then to change those specific structures or components within this design, and then find out how that would affect the other components. And he did that and was able to order those piles so that we could move forward on this bridge much quicker than would have been possible without this design. Another thing that was extremely important was that our team here at MDT, they weren't necessarily ready to absorb a model for delivery. This is part of that digital delivery effort that we're building into. But through our partnership with USCAD, through the mentoring that we've gotten from USCAD, through all of these wonderful things that we've done with this implementation, we were able to work through the process of creating a very complex set of 2D drawings from the 3D model. And this says quite a bit about how important it is to understand the complexities of a design model can be translated to a 2D plan set. And this was also seen as critically important because, as you can imagine, with this type of structure, you have a lot of subcontractors involved. In this case, we're looking at rebar. As you can see, the design was so detailed, we were able to actually order these cages based on the sheet sets and the data cut from that model. And then we saw the design actually becoming a reality. I don't, by any means, by presenting this data, want any credit for it. I just want to make sure that MDT and the amazing engineers we have are recognized, and we can get you a list of who those folks are. As I was saying, the pre-construction process was amazing, and I truly believe that Lenci and his team, and Brandon Graff and his team, you know, like we talked about, the engineers from, you know, the outside consultants, the construction team, everyone played a pivotal role. And I think the reason that this project, and I'll talk specifically about something we're very proud of here at MDT. This project wasn't about concrete. It wasn't about rebar. It wasn't about technology. This was about people pulling together to help people. And MDT is very focused on the communities that we serve. Being, you know, many people that work here, all of our families, friends travel the highways. We all are very proud of the infrastructure here in Montana. And I think this was a project everyone could get behind because it affected, you know, families. It affected everyone from, you know, small children to senior citizens. This was a community. We couldn't go in and rebuild their homes. We couldn't go in and, you know, do a whole lot, but one thing we could do is get behind getting this bridge fixed. And I think that's why it's such a passionate project from everyone, from the entry level person here at MDT all the way to the director. I mean, the director, Malcolm Long, personally went to the ribbon cutting. He was just very proud of the work that the team here at MDT put into this. There was actually an article in the USA Today newspaper that highlighted this project and the impact it had on the community. So I think that was something that was real important to Brandon and Lenci and I, is that this wasn't about the technology. It wasn't about the team of people, or I'm sorry, it wasn't about us. It was about that team of people that pulled together. And instead of figuring out why we couldn't do it, everyone said, yes, we're going to do it. Let's just figure out how. Malcolm Long, our director, he's very good at teaching all of us here at MDT to say, yes, we can. Let's not start with, no, we can't, or that's impossible. Let's say, yes, we can, and work that backwards to make that happen. And so that's a big thing here at MDT. With that being said, we talked a lot about the pre-construction process, which was amazing. What was just as amazing is this was the first time in MDT history that we actually were able to take a CAD design from pre-construction and mine data from it and do a translation to a model in Trimble Business Center. And Trimble Business Center is the tool set that we use in our construction workflows. And to explain the importance of that data transfer from a CAD design tool to the Trimble Business Center construction tool, I'd like to introduce Brandon Jones.
Hi, I'm Brandon Jones. I work at MDT as the highways engineering analyst and the highways innovation engineer. So I look at, help look at, incorporating new workflows and technology for MDT. And what I looked at for this project specifically was Pat kind of tasked me with assisting to build out that construction model for the construction crew to be able to relay the information from the plan set to the contractor. And we kind of routinely do that since 2018, but this was a more complex project and we incorporated a lot more than what we normally would have on a normal roadway project. So we've over the last 18 months or so, we've built out a pretty robust workflow on being able to build out corridors, the roadway corridors out of MicroStation, mining all the pertinent data out of that, and then bring it into Trimble Business Center. And then we recreate the corridor in Trimble Business Center, and create XML surfaces of each of our material layers. And then we're able to utilize those surfaces and supply them to the contractor so they can feed it directly into their AMG technology as like a one-to-one representation of what pre-construction designed right into the operator's equipment. But one thing that we looked at specifically in this project that we hadn't on previous projects, and it was largely due to Lenci, was we were able to put our heads together and say, like, okay, this is how we've done things for the roadway for the last couple of years. What types of pertinent information can we get out of the bridge sphere and bring into Trimble Business Center and then our survey equipment? So what we looked at doing was we built out those roadway corridors, and then we looked to examine how we could do something similar with bridge. And one of the complexities was we're grid scaled in all our other departments except for bridge. So the first thing that we had to do was we had to convert the ground scaled bridge design into a grid scaled, and Lenci and I did that, bringing that into Civil 3D. And then once we had that model in the Civil 3D, we were looking at the different components of that bridge design that would be most useful to relay to construction. So we went from ground to grid, and then we looked at some just as far as general georeference layout of the parameters of the bridge. We brought that in with mostly CAD meshes, brought that into Trimble Business Center. We're able to bring that right into the survey equipment. But one of the things that we had on this project that we hadn't had on previous projects was the cross grade of the bridge itself. It was built into the bents, so it's like complex geometry on top of the bent that we wanted to be able to relay to construction so that it would be, as close to what was designed as possible. And this would be, difficult to relay with a 2D plan set, you'd be constrained to use like a coordinate table. So you have, you know, list of coordinates laid out with your northings, eastings, and elevations. And you'd have to be able to depict that geometry from point to point is how we would normally have done it. But what we decided to do on this project was, you know, essentially wanted to relay that complex geometry to construction as closely as we could. Is we built out surfaces on top of those bents in Civil 3D, and then exported that out as land XML documents into Trimble Business Center, and looked at how that lined up with our roadway corridor model. And it was, you know, a 1-to-1 match. Everything lined up perfectly. We brought in the meshes, the surfaces from the bents, the bridge end backfill surfaces that Bridge had designed as well, and everything lined up very well. So this was like the first time that we were able to really have like a final composite model in Trimble Business Center from all our different departments and see how they lay in a geo-referenced atmosphere against each other if there's any clashes, and adjust those clashes. And, you know, it really went together better than expected. All the surfaces meshed together very well. And that was, you know, largely due to, I think, the collaboration efforts on the pre-construction side, how well they communicated. They were able to make sure their grades all meshed appropriately. So we brought that all in, and then you know, checked some coordinates against what the model was on Lenci side, and it was a 1-to-1 match. And then we brought those files and put them in the survey equipment for construction. And then while they were laying out and staging some of these components for the contractor, they're able to visualize that model right on their survey equipment and be able to relay that data right to the contractor. So as they were building out their forms on the bents, they could see the surface of those bents on their data collector. And rather than, like I said, using a 2D plan set, they could just reference that model directly. And that was the first time we had, you know, a solution that was quite as advanced as that, at least at MDT.
What Brandon's talking about is huge, because we've been able to bring information from road into Trimble before. And as Brandon said, we've been working on that since 2018. But in this case, we're able to do the bridge to Trimble as well. And in Montana, we have this weird thing between grid and ground. And so our bridges, and most folks will design their bridges in ground, meaning if you pull a tape measure, that, you know, 40 feet is 40 feet. When you go to grid, it might be slightly different from that. The different thing about Montana is that we actually have a combination scale factor that is not quite one like a lot of places, but it's different. And so to be able to do what Brandon just talked about, and to have that where he said 1-to-1, we brought that bridge from ground to grid, and then Brandon worked all that magic. And so then that is in our construction inspector's hands to inspect that and help make sure we're getting what we want. There's a high level of confidence there that we got from that. And if you go back through some of the things that Pat talked about, early work packages to buy beams, we were actually putting those early work packages together before the final design was complete. And you can imagine that management's extremely nervous about that type of thing. You want an early work package, but you don't even know what the skew is on the bridge yet. You don't even know the width of the bridge. You don't even know the length, how many spans it is. But yet, due to the confidence that we gained from having that bridge model that Pat was showing, he showed a lot of great stages of that bridge design as it went through pre-construction. Having that confidence is what allowed our team to confidently say, we're working towards this, and we can change these dimensions here and there ever so slightly. And we did that. We went from 30 degrees to 20 degrees when we got more hydraulic information for the skew. All that geometry is captured in that model. And why I'm tying this into Brandon's section is because that whole bridge was changing constantly through pre-construction, and we're adapting everything. The cool thing is we're working with one model. and we're tweaking that model to get it just perfect for this site. And then we finalize those. We have our early work packages working towards that. We have our contractor working real time with us, getting lead times on, can we go pre-stress beams? We actually had to go reinforce concrete beams because of lead times in this case. So we're doing all these things real time, and it all comes back to having that model. If we wouldn't have had the model, I don't think we would have had the success that we had, given the other challenges with supply issues, and a lot of states are having those problems. That's no surprise there. But to overcome those with our early work packages is due to the confidence that we got. The skew and the grade complicates bridges a lot. And that's where I'm tying back into Brandon's piece here, because we had these really complicated bents and we built that whole grade and skew. Those bents aren't flat on top. They're not a constant 2%. They're actually a really complex 3D surface. And so as that bridge goes across that skew and down that grade, those beams are all sitting perfectly in line with that roadway. So a car will never notice the difference. And that was all built into the model. The road surface literally cut the top of those piers off. And then Brandon took those complex surfaces and stuffed it right into the survey equipment. And so when he says, when we match that 1-to-1, you can imagine the level of confidence that we had in this relatively complex geometry for this bridge for it all to work out. So just a huge shout out to Brandon. I know, I don't know if other states are doing that yet, but it was huge for us here at Montana to be able to say our pre-construction model is now, converted to grid and now out in our construction inspections teams, survey equipment essentially. So huge shout out to Brandon there.
Oh yeah, this is just the Trimble Business Center model. You can see the roadway corridors tying into the bridges. So we have in that model the corridor meshes, and you can see the surfaces peeking out through that just a little bit as you rotate it about, and you can see how cleanly the roadway corridor surfaces tie into that skewed bridge. So yeah, it was a lot better than I expected. I kind of expected when we brought all this into one place that there were going to be some surface meshes, or surface conflictions, but it all tied in pretty well.
So you asked Todd about two models, one story. So the story is Denton, Montana, and these are the two models. One being the pre-construction model using the Autodesk suite of tools, and one being the construction model using Trimble Business Center. Now, how does this all relate to US CAD? Well, I really want to emphasize that during this entire process, US CAD was working with us in regards to this Autodesk implementation. And so we had access to technical engineers. We had access to, of course, Matt Vega. And through collaboration, through training, and through the assistance of creating new workflows, we were able to capture a great deal of information. And I want to say that US CAD's been a great partner, and we really have appreciated their involvement here at MDT. And we look forward to doing more and more of these types of things as we move into the next few years, collaborating with them on the road side, just as we have on the bridge side. There are, of course, some development and design engineers at Autodesk that put a lot of effort into helping MDT and the bridge department. Just a lot of great people through our relationships with Autodesk as well as with US CAD. Not just with this project, but they're helping us understand the two model, one story concept on future projects. So I can start by telling you that it's not just what this project has allowed us to do for Wolf Creek, but it's what this project is going to allow us to do in the future. Currently, Brandon Jones is leading an effort doing a proof of concept on creating a digital as-built, or as some in the industry call it, a digital twin of the constructed bridge. And so currently we're working on workflows to take both of these models to look at the various attribution of all the parts and pieces and of all the parametric design elements, and how we use that for construction and what might have changed, and then work with the maintenance crew as well as the construction staff to develop a life cycle digital twin of this project, that will help us in creating digital twins as well as digital as-builts for future projects. So this project is still giving us opportunities to learn and to develop new workflows. Another thing from my standpoint, and something that can't be prefaced enough, is, teamwork and collaboration. Using these tools to collaborate effectively and to be able to see dynamic changes in real time during design actually gave us a leg up. And that takes patience, that takes understanding, and that takes a commitment to work as a team. And I think we had an amazing team who, as I said earlier, didn't quite understand how we were going to get from A to Z, but were willing to try new things along the way.
I think for me, I mean, first and foremost, the tools were just that. They were a tool to be able to say, we can help this community. We think we're the best option to do this. And it's the message that, I was able to send up my chain because we had a good handle on this, and I knew we could do it. I knew there'd be a lot of bumps along the way to do it. But is what excites me about this is we were able to solve this problem for the community. And that's the first thing that we were able to do. But along the way, these tools, it's all about the people that we get to work with. And so instead of navigating through siloed information amongst the ranks here, between hydraulics and road design and coming up with this long thing, these tools allowed us to put a bridge model out in space, that happened to be in Denton, and it allowed everybody to look at it, and it allowed us to bring in the hydraulic information. It allowed us to get information to people that they needed to make their decisions. And so our old processes and schedules for project delivery were kind of thrown out the window on this, because we had this chance to say, let's just get in there and get this thing built. And then we brought our old schedule stuff back as a checklist to make sure we didn't forget anything. And so to be able to do that, really opened the window on what we could do with these tools. And then it's back to the people. Instead of navigating these really tough conversations, we're able to combine our information and just solve the problem at hand. If we saw a conflict, we could take it straight on. We didn't have to wait for 2 weeks for somebody to compile information the way we've always done it. We're able just to knock it out because we had our information combined. That's those InfoWorks tools. That's being able to bring it all in and see the same things. And we're talking construction people. We're talking our district construction people, which know Denton. They know what we want. We brought these models in front of the county commissioners in Ferguson County, and we showed them our model. And that was kind of a neat thing. I'm all the way across the state. So our contractor, Craig Lean, actually had me on his laptop in front of the commission, and I'm spinning these models. And so that's a pretty powerful sign of, I think, collaboration when we're all able to point at one thing and say, this is what we want to do. And somebody else can say, oh, I need a slight adjustment. And the cool thing is that combines everybody together. That's a huge difference now, is to be able to say, yes, we can actually easily change that bridge model to accommodate that concern. We can adjust this to meet that roadway requirement. Or similarly, I can show Rebecca Barbula in this case our concerns about the hydraulic spread width and everything. And so she was able to tweak some stuff on our alignment to be able to make sure we drain just a little bit better. And we were able just to have those conversations and point at the same things. When she changed that alignment, my model's updating. And so it's that ability to actually work together instead of kind of butt heads a little bit that really stood out to me. And I think that's what I'll always remember. It's what I'll always strive for on our next project. So I think for me, mine's not as wholesale as Pat's was, but I think just more on the ground. It was a cool way to do a project, and I certainly hope that we can take the lessons learned and get them into more of our projects for that efficient delivery. And it's people like Brandon. We hadn't really had a chance to dig in on anything, and so it's pretty cool to roll up our sleeves. Brandon's usually doing all his magic over here, and I'm over here. And so it's just cool to say, hey, I have this information. And he said, hey, I've got this. And I think, Brandon, seriously, that took us an hour and a half, maybe, from how do we do this to checking our alignment stations and offsets out to the third digit and saying, hey, we got this. And so that's pretty powerful to be able to do that level of handshake in an hour and a half.
Having an attitude where you embrace change and new technologies can be pretty powerful if you have, that attitude where this is the way we've always done it. You just don't really, you can't realize what you might leave on the table. And that probably goes for any industry, and it also helped, I think, a lot to where like we had kind of a diversified talent within all the different departments, because if it would have just been Lenci twirling and creating the bridge model, then, we wouldn't have been able to make the complete composite model at the end. We needed somebody who had, that same type of mindset in hydraulics and road design, and then, survey and construction. And so it was important to have like that diversified team who had the correct mind state in each of those departments to be able to bring it all together.